In this video, we're going to be solving two-step equations. So our essential questions are, what is a two-step equation and how do you solve two-step equations? So first of all, what is a two-step equation? A two-step equation is an equation that contains two operations. So all of the equations we've solved so far in our videos have only contained one operation. We learned how to solve addition and subtraction equations, and we learned how to solve multiplication and division equations. Now what we're going to do is we're going to have combinations of those operations. So we're going to have two operations in the equation, and we still need to solve to find out the value of the variable. So I have here three examples of two-step equations that what two-step equations might look like. So if you look at this first one, 5x minus 7 equals 12, this equation contains two different operations, and you'll see that it contains multiplication here with the 5x, and minus 7, it contains subtraction. So there are the two operations in this equation. The next one, g divided by 8 plus 12 equals 14. This one contains division and addition. And then the last one, 10b plus 7 equals 19. That 10b is multiplication, and the plus 7 is addition. So we're going to learn how do you solve these types of equations. How do you find the value of the variable if there's two operations in the equation? So how do you solve a two-step equation? Well, surprise, surprise, there are two steps to solve a two-step equation, hence the name two-step equation. First thing we're going to do is undo any addition and subtraction using those properties of equality. So essentially, we're going to be solving two separate equations at once. We're going to first solve the addition or the subtraction part of the equation, and then we're going to undo any multiplication or division using properties of equality. So we're going to undo that addition and subtraction the exact same way we did with our addition and subtraction equations, and then we're going to be left with another one-step equation that's just multiplication or division, and we'll solve those just like we did with our other multiplication and division equations. So a couple of examples here. 8x plus 3 equals 27. So what I want to identify first are what are the operations that are in this equation. I have multiplication and I have addition. The first thing I want to do is undo the addition. Any addition or subtraction needs to get undone or reversed first. So the opposite of adding 3 would be subtracting 3. So that's what I did to both sides of this equation. I subtracted 3 from both sides of the equation. 8x plus 3 minus 3 just gives me the 8x, because that becomes 0, and then 27 minus 3 is 24. So now I've undone the addition. There is no more addition in this equation. So then the next thing I need to do is undo that multiplication. Now it looks just like an equation that we've already solved, a multiplication equation. So the opposite of multiplying by 8 is dividing by 8. So I divided both sides of the equation then by 8, and 8x divided by 8 is just x. And 24 divided by 8 is 3. So here's my solution, x equals 3. And as always, you can plug that back into the original equation and check it. 8 times 3 plus 3. 8 times 3 is 24. 24 plus 3 is 27. So that is the correct solution. You can always check those just like we did all of our other equations, and I would highly recommend doing that. Next example, h divided by 6 minus 4 equals 8. Here we have two operations. We have division and we have subtraction. So we're going to undo the subtraction first. And the opposite of subtracting is adding. So the opposite of subtracting 4 would be adding 4. So I added 4 to both sides of this equation. And h divided by 6 minus 4 plus 4 is just h divided by 6. The minus 4 plus 4 just becomes 0. And then 8 plus 4 is 12. So now I'm left with another one-step equation after getting rid of the subtraction. H divided by 6 equals 12. So I need to undo the division. What's the opposite of dividing by 6? That would be multiplying by 6. So I'm going to undo the division by multiplying both sides of this equation by 6. H divided by 6 times 6 is just h, and 12 times 6 is 72. So here's my solution, h equals 72. And then again, if I check that by plugging that back into the original equation, 72 divided by 6 is 12, 12 minus 4 is 8, and 8 equals 8. So I know my solution is correct. So it seems like a lot, but once you get the hang of solving two-step equations, it's really quite easy to do. Just make sure that if you're in doubt, you check your answer. So let's solve these equations. 10x plus 7 equals negative 53. I drew my line down here already so that I have my equation divided into its two sides. So I'm looking at the side with the variable, and I have multiplication and I have addition. Well, the first thing I want to do is eliminate that addition or undo the addition. So I'm adding 7. So what I want to do is subtract 7 from both sides, and that will get rid of that addition on the side with the variable. Always working on the side with the variable. So 10x plus 7 minus 7 is just 10x, and negative 53 minus 7 is negative 60. So now that first step is done. So step 1 was to get rid of the addition. Now I need to get rid of the multiplication or undo the multiplication. So I'm going to divide both sides by 10. So 10x divided by 10 equals negative 60 divided by 10, and 10x divided by 10 is just x, and negative 60 divided by 10 is negative 6. And there is my solution, x equals negative 6. Now, in the interest of time and keeping this video relatively short, I'm not going to show the work for checking it, but I would definitely check that. So if you plug that back into the original equation, 10 times negative 6 is negative 60. Negative 60 plus 7 is negative 53. So I know that that is correct. So step 1 in red, step 2 in blue, and I'm done. So you can see once you get the hang of that, it does go quite quickly. Next one, m divided by negative 9 minus 15 equals negative 4. Again, I divided the equation into its two parts, and I'm looking at the side with the variable. I have division and I have subtraction. I need to undo the subtraction first. So undoing, or the opposite of subtraction, is addition. So the opposite of subtracting 15 would be to add 15. So I'm going to undo this by adding 15 to both sides of this equation. And m divided by 9 minus 15 plus 15, that becomes 0. So all I have is the m divided by negative 9. And negative 4 plus 15 is a positive 11. So there's the first step. I got rid of the addition, or sorry, the subtraction. And now all I have left is the division that I need to get rid of. So I'm going to use multiplication to do that. So I'm going to multiply both sides by negative 9, since that's what I'm dividing by. And those cancel each other out, leaving me just m, and that is negative 99. M equals negative 99. And again, I would go back and double check that. Negative 99 divided by negative 9 is positive 11. 11 minus 15 is negative 4. So my solution does check out. So again, step 1 in red, step 2 in blue. Negative 2b minus 18 equals 44. Here I have multiplication and subtraction in this problem. So I'm going to undo the subtraction first. And the opposite of subtracting is adding. So I'm going to add 18 to both sides of this equation. And these become 0 on the left-hand side, leaving me negative 2b equals, and 44 plus 18 is 62. So there, step 1 is done. So now I need to get rid of the multiplication, or undo the multiplication. I'm going to use division. So I'm going to divide both sides by negative 2. And that's negative 31. And there is my solution. Again, if I check that, negative 2 times negative 31 is 62. 62 minus 18 is 44. My solution checks. Next one, negative 44 equals v divided by 9 minus 38. On the right-hand side, I have division and subtraction. So I want to undo the subtraction first. I'm going to use addition. So I'm going to add 38 to both sides of the equation. To undo that subtraction. And on the left-hand side, negative 44 plus 38 is negative 6. And then these minus 38 plus 38 just becomes 0. So I just have v divided by 9. So there's step 1. I got rid of the subtraction, or undid the subtraction. And now I need to undo that division. So I'm going to multiply both sides by 9. Negative 6 times 9 equals v divided by 9 times 9, and then those cancel each other out, leaving me just v, and negative 6 times 9 is negative 54, and there's my solution. Negative 54 equals v, and again, if I put that back and check, negative 54 divided by 9 is negative 6. Negative 6 minus 38 is negative 44. So that solution checks as well. I know I've got the right answer. Last two, negative 34 equals 5f plus 6. On the right-hand side, I have multiplication and addition. So I'm going to undo the addition first by subtracting 6, since I'm adding 6. Negative 34 minus 6 is equal to 5f plus 6 minus 6. And then again, the plus 6 and the minus 6 becomes 0, so all I have is 5f. And negative 34 minus 6 is negative 40. And then that's step 1. Step 2 would be to eliminate this multiplication. And I'm going to divide both sides by 5. Negative 40 divided by 5 is negative 8. And 5 times f divided by 5 is just f. There's my solution. Negative 8 equals f. And if I plug that back into check, 5 times negative 8 is negative 40. Negative 40 plus 6 is negative 34. My solution checks. Last one, s divided by negative 3 plus 19 equals negative 5. I have division and addition. I want to undo the addition. So I'm going to subtract s divided by 3, or s divided by negative 3 plus 19 minus 19 equals negative 5 minus 19. And this becomes 0, the plus 19 minus 19. So all I have is s divided by negative 3 equals, and then negative 5 minus 19 is negative 24. And that's step 1, got rid of the addition. Step 2, get rid of the division, or undo the division. I'm going to multiply both sides by negative 3, since I'm dividing by negative 3. And those cancel each other out, leaving me s. And negative 24 times negative 3 is a positive 72. And there's my solution. And again, if I check that, 72 divided by negative 3 is negative 24. Negative 24 plus 19 is negative 5. The solution checks. So you can see that this gets quite repetitive, and you get the hang of it once you do several of these. We're always going to undo the addition or subtraction, then undo any multiplication or division. It's kind of like the reverse of the order of operations, because we're undoing everything. We're kind of working our way back to the variable. And again, show your work. You have to write this stuff down. As you can see, there's a lot of numbers going on here, so trying to do this all in your head can get quite difficult, and your chances of error go up dramatically.